Welcome to my channel. Today we will study Fibonacci sequence and golden ratio. A famous mathematician. Fibonacci, 1170 to 1250, is a short for the Latin Filius Bonacci, which means the son of Bonacci, but his full name was Leonardo Pisano. He introduced the Hindu-Arabic number system into Europe. About the origin of Fibonacci sequence. Fibonacci sequence was discovered after an investigation on the reproduction of rabbits. Fibonacci's rabbits. Fibonacci's rabbits. Problem. Suppose a newly born pair of rabbits, one male, one female, are put in a field. Rabbits are able to mate at the age of 1 month, so that at the end of its second month, a female can produce another pair of rabbits. Suppose that the rabbits never die and that the female always produces one new pair, one male, one female, every month from the second month on. How many pairs will there be in 1 year? N first month only 1 pair. N second month 2 pairs of rabbits. N third month 3 pairs of rabbits. At the end of the 4th month, the first pair produces yet another new pair, and the female born 2 months ago produces her first pair of rabbits also, making 5 pairs. Thus we get the following sequence of numbers. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. This sequence, in which each number is a sum of 2 previous, is called Fibonacci sequence. So there is the simple rule: add the last 2 to get the next pair. So 144 pairs will be there at the end of 1 year. Fibonacci sequence in nature. Spiral seen in the arrangement of seeds in the head of this sunflower number. Spiral seen in the arrangement of seeds in the head of this sunflower number 34 in a counterclockwise direction, and 55 in a clockwise direction. Note that 34 and 55 are the 9th and 10th Fibonacci numbers respectively. Also note that the flower itself has 34 petals. Pinecones clearly show the Fibonacci spiral. Note that 8 and 13 are consecutive Fibonacci numbers. Now notice the number of petals on a flower are often Fibonacci numbers. The Fibonacci numbers can be found in pineapples and bananas. Bananas have 3 or 5 flat sides. Pineapple scales have Fibonacci spirals in sets of 8, 13, 21. The golden ratio. The golden ratio is an irrational mathematical constant, approximately equals to 1.6180339887. The golden ratio is often denoted by the Greek letter phi. So, Q equals 1.6180339887. The golden ratio, also known as golden ratio, golden section, golden cut, divine proportion, divine section, mean of Phidias, extreme and mean ratio, medial section. 2 quantities are in the golden ratio if the ratio between the sum of those quantities and the larger one is the same as the ratio between the larger one and the smaller. Now focus the written equation. One interesting thing about phi is its reciprocal. 1/phi equals 1 divided by 1.618 is equal to 0.618. It is highly unusual for the decimal integers of a number and its reciprocal to be exactly the same. A golden rectangle is a rectangle where the ratio of its length to width is the golden ratio. That is, whose sides are in the ratio 1 minute and 1.618 seconds. The golden rectangle has the property that it can be further subdivided into 2 portions: a square and a golden rectangle. This smaller rectangle can similarly be subdivided into another set of smaller golden rectangle and smaller square. And this process can be done repeatedly to produce smaller versions of squares and golden rectangles. Golden spiral. Start with the smallest one on the right. Connect the lower right corner to the upper right corner with an arc that is 1/4 of a circle. Then continue your line into the second square on the. With an arc that is 1/4 of a circle, we will continue this process until each square has an arc inside of it, with all of them connected as a continuous line. The line should look like a spiral when we are done. Golden triangle. The golden triangle is a special isosceles triangle. The top angle is 36 degrees while the bottom two angles are 72 degrees each. Relation between Fibonacci sequence and golden ratio. The Fibonacci sequence is 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. Now have an eye on the given sequence of the numbers. Aha! Notice that as we continue down the sequence, the ratios seem to be converging upon one number, from both sides of the number. If we continue to look at the ratios as the numbers in the sequence get larger and larger, the ratio will eventually become the same number, and that number is the golden ratio. Now you can focus and observe the given Fibonacci sequence. Golden ratio in nature. Nautilus shell also represents golden ratio. Golden ratio in art. Many artists who lived after Phidias have used this proportion. Leonardo da Vinci called it the divine proportion and featured it in many of his paintings. Mona Lisa's face is a perfect golden rectangle, according to the ratio of the width of her forehead compared to the length from the top of her head to her chin. Golden ratio in the human body. Observe golden ratio in your fingers. Also observe golden ratio in your hand. Golden ratio in the face. The blue line defines a perfect square of the pupils and outside corners of the mouth. The golden section of these four blue lines defines the nose, the tip of the nose, the inside of the nostrils, the two rises of the upper lip and the inner points of the ear. The blue line also defines the distance from the upper lip to the bottom of the chin. The yellow line, a golden section of the blue line, defines the width of the nose, the distance between the eyes and eyebrows and the distance from the pupils to the tip of the nose. The green line, a golden section of the yellow line, defines the width of the eye, the distance at the pupil from the eyelash to the eyebrow and the distance between the nostrils. The magenta line, a golden section of the green line, defines the distance from the upper lip to bottom of the nose and several dimensions of the eye. The front two incisor teeth form a golden rectangle, with a phi ratio in the height to the width. The ratio of the width of the first tooth to the second tooth from the center is also phi. The ratio of the width of the smile to the third tooth from the center is phi as well. Golden ratio in human body. The white line is the body's height. The blue line, a golden section of the white line, defines the distance from the head to the fingertips. The yellow line, a golden section of the blue line, defines the distance from the head to and the elbows. The navel. The green line, a golden section of the yellow line, defines the distance from the head to the ectorals and inside top of the arms. The section portions of the magenta line determine the position of the nose and the hairline. Although not shown, the golden section of the magenta line, also the short section of the green line, of the head in half, defines the width of T-width of the chest and the hips. Golden mean gauge. Now observe it. Now here are some more examples of golden section.